All right, so we're going to solve some more equations with decimals. And we're going to start off with these two. And so what we have to do is we have to basically just get x's on one side, our numbers on the other side. And then when we divide by decimals, we just have to do the appropriate things. So here, what we're going to do is we're going to take and add 45.22 to both sides. So when we do that, those cancel. We get a negative 1.33x equals 45.22. Now I could have taken the 1.33x over, but it really doesn't matter. It's always going to be a negative answer when we get done. So I just took the number over instead of the variable. So now I'm going to divide by negative 1.33. And so those cancel, and I get x equals a negative. Now, 45.22 over 1.33. I have to move the decimal twice to get it to a whole number. So I have to move it twice in the numerator as well. And so really what I'm going to do is I'm going to take 133 into 4522 point however many zeros I need. Now if I take 133 times, say, 3, that's going to be 993. If I had another 133, how much does that put me at? 9, 10, 11, 12, 13, 3, 4, 5. That puts me over. So just 3 is all I can put there. So that's going to be 399. So subtract that off. So that's a 3, that becomes a 14. So now I have 12. So I have a 3. And then 14 minus 9, that's going to give me a 5. 3 minus 3 is 0. Now I bring down my 2. All right, so this was 532. So if I put a 4 here, that's equal to 532. So I subtract that, that's 0. So then I get my x is equal to a negative 34. So that one actually worked out quite nicely because I went ahead and I wanted to see if the next one bigger was going to work, and it gave me 532. That was my next subtraction, so that was kind of nice, and that worked out nicely there. All right, the next one. Here I've got a variable, and then a number. So I think I'll take the variables over, and then I have less things to do. So I'm going to add 0.6x to both sides. And so I have a 6.3 equals. Now I have an x, that's a 1, that's going to be a 2.1. All right, so now I have 6.3 equals 2.1x, so I have to divide by 2.1. So, those cancel. So x is equal to 6.3 over 2.1. Move the decimal, both of them, one time. So that gives me 63 over 21. Now, if I think about 21, if I multiply that by 3, that's going to give me 63. So 21 goes in here once, goes in here 3 times, and so my x equals 3 is going to be my solution to this problem. Okay, so it's another one of those, works out nicely. And again, I'm going to leave the check to the student for this problem. All right, so here we have to get rid of parentheses. And so to get rid of parentheses, we have to distribute. And when you do the distribution, remember, we have a negative here, so both of the answers are going to be negative when we get done. So we have a 0.7 times a 0.2, and that's going to be a negative. And if we need to, we can write over here what 0.7 times 0.2 multiplied together is. Well, 2 times 7 is 14. Well, I don't have any molar multiplication to do, so I just have to move it 2 decimal places. So that gives me a 0.14. So it's a 0.14, and it has an x on it. Now I have to take 5.48 times 0.7, and it's going to be a negative again, so I can go ahead and write that negative. So now I have 7 times 8 is 56. That's 28, 29, 30, 31, 32, 33. That's 35, and then 38. and I move it 1, 2, 3. So 3.836. That's all equal to 16.45. All right, so I've got the 0.14x here, that's negative, and I'm going to put all the numbers to that side. So I'm going to add 3.836 to both sides. Now when I do that, that cancels there. So a negative 0.14x equals, now let's go ahead and add a 0 here as a placeholder so I can add easily. So that's a 6, that's an 8, that's a 12, my decimal, carry 1, that's 10, carry 1, that's 2. And it's positive, and so now I divide by a negative 0.14. So I divide that by a negative 0.14. So those on that side are gone, and I have x equals, that's a negative. Now, when I do that, I have to move the decimal 1, 2 here, and 1, 2 here. So it's really 2028.6 divided by 14. Well, we could reduce that, but let's just divide it. It's just as easy, I think, in this case. So 2028.6. Who knows how many more zeros we'll need. So 14 goes into 21s. That's 14. Subtract. That's 6. Bring down a 2. So 14 times, I don't know, 5. It's going to be too big, so let's take it times 4. That's 16. That's 5. So we have a 4. That's 56. Subtract. That's going to be 6. Now we need to bring down 8. Let's say 14 times 5. That's going to be, that's 20. That's going to be 70. That's too big, so I guess we do another 14, or another 4 rather. And so that's going to be 56 again. Subtract, that's going to be 2. That's a 1. That's less than 14, so we're okay. So now we need to bring down our 6. So 14 times, maybe 8. So that's 32. That's going to be 11. If we add another 14, that's 126. So that's times 9. And so we need a 9 there instead. So it's 126. Subtract, that's 0. So here, x equals negative 144.9. All right. So in this case, I multiplied by 8. It was too small. I had to add another 14, and that put me at 126. So then I had to add 1, so that was times the 9. Okay. So again, make sure when you distribute, you carry that negative sign through both of them. And then after that, go ahead and take the numbers on one side, the variables on the other side, and then that should get you the correct answer once you divide. Again, when you have a decimal, you have to move it over to get a whole number on the denominator, and so you have to move it over in the numerator as well. All right, so this one, Marion needs to create a rectangular garden plot covering 223 square meters. If the width of the plot is 8.3 meters, find the length to the nearest tenth of a meter. All right, so let's draw a picture. What do we have? All right, so we have the area is 223 meters squared. That's area. And we know the width is 8.3 meters. And we want to know the length. Okay. Well, what do we know about area? Well, area is equal to length times width. So now we just plug in what we know and solve for what we don't know. So area we know is 223 equals length, don't know that, times that, which is 8.3. So if I divide by 8.3, divide by 8.3, then we have length equals 223 divided by 8.3, but I need to move over one decimal place here, so I'm going to have to also move over one here. So what I'm going to do is I'm going to divide 83 into 2230, and it says round to the nearest tenth, so I have to go out to at least the hundredth. And so what do we have? 83 times 3 is going to give me 24, so that's too big. So I have to take it times 2. That's going to be 6. That's going to be 16. So that's a 2. That's 166. Subtract. Well, that's a 1. That's 11. So 6 from 13 is 7. 6 from 11 is 5. Now we bring down our 0. So now what do we have? We have 83 times what to get to 570. If we take it times 8, that's too big. 7, that's going to be too big. So let's try 6. So 6 times 3 is 18. 6 times 8 is 48, 49. And if we added another 83, I think that's going to be too big. So that's 8, 9, 10, 11. That's going to be 18, 581. Yep. So that's going to be a 6. And that was, now I can't read my own writing, 498 it looks like. All right, so we carry around, that's going to be 16. So 10 minus 8 is 2. 16 minus 9, that's going to be 7. Now we have to bring down our 0. All right. So what do we have? 83 times, let's see, 8 maybe? That's 24. That's 64, 65, 66. And 83 more, I think, is going to be too big. So that's a 7. That's 14. That's 7. So yeah, that's too big. So we have, that's going to be an 8. And we have 664. So now we carry again, borrow 10 minus 4 is 6, 11 minus 6 is 5, and now we have a 0. All right, so it looks like we're going to have a 6 again. And when we took it times 6, that was going to be 498. Subtract, that's a 4, that's a 15, so 10 minus 8 is 2. 9, 10, 11, 12, 13, 14, 15 is 6, and that's less than, and so we should be done because we want it rounded to the nearest tenth. So our rounding digit is a 6. That's bigger than 5, so we're going to round that up. And so it looks like L is going to be 26.9 meters. Okay. And so that will be what our length is to the nearest tenth of a meter. Now it's not exact because if we took 26.9 times 8.3, that's not going to be exactly 223 meters squared. But within a rounding error of the 1 decimal place, which is what they want it to the nearest tenth, that's going to be our answer. All right, the next one. In 2008, California had 2.7 million undocumented residents. This is double the number in 1990. How many undocumented residents were there in California in 1990? Well, let's say X equals number of undocumented residents in 1990. So we know that in 2008, there were 2.7 million, which was double the number in 1990. So if X is 1990, 2 times X is equal to 2.7 million. And we'll just leave off the million, we'll just have 2.7. So if we divide by 2, X equals, well, now we just take 2.7 divided by 2, put our decimal there, so that's a 1, that's 2, subtract, that's 0, bring down our 7, that's 3, that's going to give us 6, subtract, that's 1. Now if we add a 0, that's going to give us a 5. So it looks like that when we do that, that's going to give us 10, subtract that 0. X is equal to 1.35 million people, okay, that were undocumented residents in California. So that one was another simple one where we just had to take and divide by a simple number, and we just had a decimal division basically to work with.